I wanted to start this discussion with this picture of a floor plan, and it's one that is very near and dear to my heart because this is the floor plan of my wife's and my kitchen in our house and how we intend to have it remodeled in a couple of months. And so if you look at this very carefully, we can see some things here. Here is the hood, and that means that that's where the stovetop is going to be. But I know that this is right here an island, and this is the kitchen table right here. I know that there's going to be like I said, there's sink right there, and so anyway, the idea is that you have to, when you draw something like this, you have to create something called a scale, and the concept is really related to something called dimensional analysis. So now when we talk about dimensional analysis, let me introduce you to some ideas here. It's very impractical to make drawings the size of the real room. So we make a scale drawing to help us carry things around in portable views of the room. Um, and we have to make a scale to make it all work. So very typically, the scale that you see in something like this is 1/4 inch represents 1 foot. Now, when you say that, 1/4 inch of the drawing is representing 1 foot of the house. So this is what's real here, and this is what's scaled here. So I think what I want to do is introduce you to an idea, since we're talking about both measurements of lengths of things in inches and in feet, but we don't want to confuse when we're talking about inches on the drawing versus inches on the floor, because we could say 6 inches is 1/2 foot and be talking about 1/2 foot of the floor. So we have to actually say something like this now, that if 1/4 inch is equal to 1 foot, and I'm going to say it this way, that 0.25 inches, and when I say inches, just going to circle it, and is equal to 1 foot. And that way we can say, okay, now 1 foot is the real 1 foot versus 0.25 inches is representing that real foot, but it's representing it scaled so that it fits on the paper. Now if we do that, we can assume this now too, that we can create that 1 foot is for every 0.25 inches, or we can say 0.25 inches for every 1 foot, depending on what we're wanting to say. Now, these become conversion factors when you see them this way, and you'll see what I mean. Because you see, let's take for instance, I know that from about here to here is about 22 feet. 22 feet. So I'm going to say 22 feet, and I'm going to show you how we use dimensional analysis to do this. You see, what we want to do is we actually want feet to cancel, because I want to see how long is 22 feet on the drawing if this drawing uses this scale of 1/4 inch represents 1 foot. So we can say 22 feet and create a tall parentheses and put a fraction bar in there. And we're going to say this. We're going to just go ahead and put in the appropriate dimensional piece. We call that the multiplication factor, and there's 1 foot down here. And the reason why I put 1 foot down is because feet are going to cancel when this works. I'll show you how. And then, so I put the 0.25 inches, and I'm going to circle that because that's the scaled inches. And then I'm going to close this off. Now I'm going to do the multiplication. So we have 22 times 0.25. And look at what happens here. When you multiply, and this is over 1, but the feet actually cancel each other out because you end up with feet over feet, and that makes 1. And then we're left with inches. So this calculation right here is going to give us 5.5 inches on the drawing represents the length of the living room there.